Picture this: an AI assistant that understands words, anticipates needs, collaborates with other digital agents to solve complex problems, and operates with energy efficiency. Yet, the same AI might bend rules unexpectedly or consume power like a small city's grid. This represents the thrilling, sometimes unnerving edge of artificial intelligence research today. Welcome to AI Frontiers, where dense papers from the arXiv preprint server are transformed into captivating stories. Today, insights from a combined batch of 27 recent papers, all tagged under computer science, artificial intelligence, from uploads around November 5, 2025, and related dates are synthesized. These works span groundbreaking ideas in efficiency, collaboration, and ethical AI. In this episode, a cohesive tale of AI's evolution is synthesized from these 27 papers, drawn from two clusters on the arXiv preprint server, all falling squarely in cs.AI, representing the pulse of artificial intelligence research. The first cluster of 15 papers, uploaded on November 5, 2025, tackles topics from energy-hungry large language models to multi-agent systems that mimic human teamwork. The second cluster of 12 papers from various recent dates delves into agentic orchestration, knowledge integration, and safety in AI. Together, they paint a picture of a field racing toward more capable, responsible systems. These technical gems are distilled into an accessible yet deep-spoken narrative, explaining jargon like inference, the phase where AI processes new inputs without dumbing down the science. How AI is becoming more sustainable, collaborative, and human-aligned is uncovered, while challenges like ethical pitfalls and scalability are highlighted. By the end, a front-row seat to AI's frontiers is provided, inspiring thoughts about its role in the world. Computer science. Artificial intelligence is the branch focused on building machines that simulate human-like intelligence, handling tasks like learning from data, reasoning through problems, understanding language, or perceiving the world via senses like vision and sound. It involves creating systems that decide, adapt, and innovate to amplify human potential. Examples include chatbots that converse naturally, recommendation engines that predict preferences, or autonomous vehicles navigating traffic. In the data-drenched era, AI revolutionizes sectors such as healthcare for faster disease diagnosis, environmental science for monitoring climate threats, and finance for optimizing investments. These papers underscore AI's dual-edged nature, immense power for good, like automating scientific discovery, but risks like energy waste or unintended behaviors. Historically, AI has evolved from rule-based systems in the 1950s to today's deep learning models, fueled by massive datasets and computing power. Its importance lies in solving complex real-world problems, such as AI agents coordinating to detect algal blooms from satellite images, or debating credit risks like seasoned analysts. Yet, as shown in these papers, the field is maturing towards sustainability and ethics, ensuring AI operates responsibly. A prominent theme across these papers is energy efficiency and sustainability in AI models. Several works from the first cluster highlight the massive energy costs of large language models during inference, the phase where new inputs are processed. One paper proposes browser tools to track carbon footprints. This theme connects to scalable systems, emphasizing greener practices amid rising data center demands. For instance, Karabaka et al. Measure inference footprints, revealing the need for sustainable designs. Overall, this reflects AI's evolution toward reduced power hunger without losing capability. Another powerhouse theme is multi-agent systems and coordination, appearing across both clusters. These systems involve AI agents teaming up for tasks like scientific discovery, code untangling, or multimodal reasoning that handles text, images, and audio. For example, Michener et al. Introduce an AI scientist that automates research cycles. Lin et al. Enable multimodal reasoning via agent coordination for diverse data types. This approach enhances tasks from financial analysis to detecting environmental issues like algal blooms, illustrating how AI mimics human collaboration to tackle complexity. Building on multi-agent systems, strengths and applications are evident. Systems use debate-style agents to improve judgment quality in high-stakes decisions, such as financial analysis. A key technical concept is retrieval-augmented generation, which pulls from knowledge graphs for accurate, time-sensitive responses. This supports automation in research, code analysis, and multimodal applications. Overall, it highlights AI's shift from isolated tools to ecosystem players, addressing real-world complexity through coordinated efforts. Interpretability and alignment for trustworthy AI weave through many works. This theme focuses on making AI decisions transparent and aligned with human values. Papers employ crowdsourced bounties to detect misalignments, such as agents exploiting instruction loopholes. Cultural fairness in prompts is ensured, and causal relations are extracted from data, like in educational contexts. This ties into ethical AI, reducing risks in applications such as psychological profiling and making the black box of AI more transparent and safe. Critical insights from the papers include several game changers. Inference in large language models often consumes more energy than training, with measurements across thousands of setups revealing potential for significant reductions via optimizations, as shown by Caravaca et al. Multi-agent systems can detect silent failures like behavioral drifts with 98% accuracy using tools like XGBoost based on curated datasets of real user interactions. Boosting reliability in automated workflows, debate-based multi-agent frameworks slashed financial analysis time from 30 minutes to under 2 while improving judgment quality. Crowdsourced bounties uncovered reproducible AI misalignments, providing datasets for safer designs. In psychological profiling, large language models achieved R-squared scores over 0.89 in predicting traits, suggesting emergent understanding but flagging privacy concerns. Common methodologies across these papers drive AI research forward. Multi-agent architectures coordinate specialized agents under a leader, dividing complex problems for flexibility, as seen in systems like Cosmos and Agent Omni, though coordination overhead can lead to inconsistencies. Retrieval-augmented generation with knowledge graphs enhances reasoning by pulling structured data, reducing hallucinations but facing challenges in scaling and managing implicit connections. Benchmarking with curated datasets tests AI rigorously, exposing gaps like multilingual weaknesses, yet dataset biases and labor intensity limit comprehensiveness. Reinforcement learning foundations train agents through rewards, fostering long-term planning but suffering from sample inefficiency and credit assignment issues. These approaches blend innovation with pragmatism, highlighting the quest for efficient, ethical tools. The first selected paper is From Prompts to Power, Measuring the Energy Footprint of LLM Inference by Caravaca et al., 2025. It was chosen for quantifying AI's environmental impact and its potential to influence policy. Objectives center on analyzing inference energy drivers, providing empirical data, and developing predictive tools. Methods involve over 32,500 measurements across 21 GPU configurations and 155 models. Using VLLM for optimized inference, training a regression model, and creating a browser extension for real-time carbon visualization. Findings show inference energy often exceeds training, with optimizations slashing usage by up to 10x and large deployments rivaling national consumption. Significance lies in shifting AI toward eco-friendly designs, guiding hardware innovations and policies like carbon taxes on operations. The second selected paper is Cosmos, an AI Scientist for Autonomous Discovery by Michener et al., 2025. It was chosen for automating science and representing multi-agent innovation. Objectives aim to engineer an AI for full scientific workflows, accelerating discoveries in data-rich fields. Methods feature Cosmos, a multi-agent framework with a central knowledge graph, coordinating agents for data analysis and literature querying, tested across domains with human evaluations. Findings indicate generation of outputs equating to 6 months of human work, with 79.4% accuracy and novel insights. Significance includes democratizing research for applications like drug discovery, with ethical safeguards needed against misuse. The third selected paper is Agent Omni, Test Time Multimodal Reasoning via Model Coordination for Understanding Anything by Lin et al., 2025. It was selected for its adaptable multimodality, addressing model rigidity. Objectives focus on creating a framework for reasoning over any data mix without retraining, ensuring interpretability. Methods use a master agent coordinating specialist models at test time, parsing intents and integrating via reasoning chains. Evaluated on benchmarks, findings show top scores across modalities with modular transparency, outperforming baselines. Significance enables rapid deployment for real-world applications like surveillance, promoting interoperability despite dependencies on submodel quality. These papers point to exciting future directions amid challenges. Hybrid human-AI workflows are expected, such as augmented science where systems like Cosmos assist researchers. Zero-shot adaptability in agents will handle unseen tasks efficiently. Integration with quantum computing could address energy and scalability issues. Ethical frameworks like expanded misalignment bounties will tackle biases and cultural gaps. Innovations in proxy evaluations and graph partitioning may mitigate scaling problems without energy spikes, ensuring interpretability and paving the way for sustainable, inclusive AI. This deck was synthesized using AI tools, including GPT-Grok with model Grok 4.0709 for content generation. TTS synthesis was handled via OpenAI for narrative audio, and image generation used Google tools. A review by a human expert ensured accuracy and coherence. Potential oversights may exist, and all references are provided for verification. Subscribe to the YouTube channel for more AI research narratives and insights. The channel title is AI Frontiers. Stay updated on the latest in artificial intelligence. Hit subscribe today. In this podcast, we bring you the latest breakthroughs in computer science and AI straight from arXiv. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.